So we want to find the intervals upon which this function here, this cubic function, is increasing and or decreasing. So we'll start, by getting the derivative. So f prime of x is equal to, how about 9x squared plus 18x. And then we will get the critical values. So we'll get the critical values, and we do that, of course, by asking two questions, but we're only going to ask one here because this function is a polynomial function. It's always defined. It's a smooth, continuous curve. There's never any corners or cusps or breaks or gaps. So we don't need to ask the second question, where is it undefined? Just the first one, where is it equal to 0? So our derivative is 9x squared plus 18x equals 0. We can factor out a 9x, and that will leave us with an x plus 2 equals 0. So we're going to get these critical values. The critical values we're going to get at 0 and negative 2. Let me circle those so I can find them again. And now what we're going to do is, first of all, I'm going to rewrite f in factored form. It looks like this: 9x x plus 2, and our critical values are x equals negative 2 and 0. So I'm going to draw this number line. I'm going to label it x, and I'm going to note our two critical values. We've got one here at negative 2 and one here at 0. Now I'm going to analyze f prime in each one of these intervals. So let's come in first from this leftmost interval, any number less than negative 2. Now what I'm going to do is I'm going to run a test here. I'm going to take any one of these numbers and put it into this f prime. That's f prime, right? F prime. So if I pick any one of these numbers and put it into this, here's what we're going to get. This is just a sign analysis. I'm creating a sign chart. The 9, well, that's positive, so that's always going to be positive. So the 9 is positive. Then, if I pick any one of these numbers here, less than negative 2, and put it right here in for that x, right, pick any one of these, it's negative, put it in for x, I'll get a negative. And then if I pick a number here, less than negative 2, like negative 3, put negative 3 in here, this factor, negative 3 plus 2 is negative 1, or negative, that's all I care about. It's negative, so I'd get a negative. And then what I get is positive times negative, that's equal to a positive, and a positive says that the function is increasing. Now let's do the same in this interval. So again, I've got that 9. Now the 9 is always positive. And if I pick any one of these numbers here from negative 2 to 0, like negative 1, say I pick negative 1, just pick one, any one, as a test number. Pick negative 1. If I pick negative 1 and put it in here, it's going to be negative. I'll get a negative. And then if I put that negative 1 in here, negative 1 plus 2 is 1. That's positive. That's all I care about is the sign. So that's positive. And then I'm looking at this. A positive times a negative times a positive, that is negative. And that implies that the function is decreasing there. And then lastly, what about this interval here? Any positive number. So again, if I put any number here, the 9 is always positive. Pick any positive number, pick any number here like 1, put it in here, that's going to be positive. And then if I pick any number in here, like 1 again, 2, 3, 4, whatever you like, if I pick 1, put it in here, I'll get 3, that's positive. Multiply 3 positives together, I get a positive. That reminds me of increasing. So this function is going to be increasing on, what have we got? It's increasing down here from negative infinity to 2. Let's get that one. So it increases negative infinity to 2, open, or, that's our sign for or, then we're out here. 0 to infinity. Open parentheses because those numbers are not included. And then the function is decreasing on, well, it's that middle interval, and that goes from negative 2 to 0. There we go. So I know what this does. As I come in left to right, it's increasing then it's decreasing, then it's increasing again. So it looks like we've got our critical values, a little maximum and a relative minimum right there.